Welcome back to the channel. I'm Tim. Today we have got a box, and this is from the Future Was 8-bit, and it is a computer, it is a kit. We are going to build it and let's get on with it. This is nicely taped together. Hopefully I'm not getting too much in the way. Take that off. Turn this sideways. We have packing peanuts. Merry Christmas from the lads at the Ark Royal. One packet. I'm trying to... 2 packets. Trying to not get the peanuts everywhere because I'd only have to clean them up again. Three packets. A pink windmill Christmas colouring book. Yay! That's an A4 one. Last year's was an A5 one, and I still haven't coloured it in. So, no particular order. Right, chips, connectors, and a keyboard template overlay, and a circuit board. This is what we have. It's the Tynemouth Minstrel 4D. So, perspex, manual, switches, and a rubber, or for those of you that are American, an eraser. In English it's a rubber. Bits, more bits, connectory bits, holdy togethery bits, resisting bits. Resistance is futile. All the theory of operation, all the schematics, all the... This is an awesome manual. It really reminds you back of the manuals that you got in the old days. The VIC-20 and the C64 and the C128. Look at that. RC 2014 bus. I think we're going to have some fun with this. Awesomely produced manual. How many pages? 112 pages. We will get through most of those. This page is left blank. Board layout and assembly. We are going to build this thing. And so it begins. I'd like to thank PCBWay for sponsoring this video. Starting from just $5 for up to 10 boards, they make PCBs to your exact specification with rapid turnaround and fast delivery times. Their shared project pages give access to ready-made designs and allow makers to share their PCB layouts with others. Add to this, they can assemble your boards, do 3D printing, CNC machining, and more. Check them out at www.pcbway.com. So, the Jupiter Ace. What is it and why have you never heard of it? The Jupiter Ace was a 1982 British microcomputer made by Jupiter Cantab. It was named after one of the UK's first ever computers, the Pilot Ace automatic computing engine, built by the National Physical Laboratory in the early 1950s. The Jupiter Ace, however, does not fill a medium-sized room. Rather, it is around the same size as a Sinclair Spectrum, although the display is in black and white. Technically, it was powered by a Zilog Z80A at 3.25 MHz. It had 3K of RAM, of which 2K was used for the screen and redefinable character set. The screen was 32 columns by 24 rows in black and white. Effectively, that's 256 by 192 pixels, although it did not support pixel graphics. But it did do chunky block graphics, and the 128 characters were all redefinable. It had 8K of ROM, split between machine code and Forth. There was no BASIC. Instead, it used Forth as its programming language. In case you don't know, Forth is a reverse Polish style language. Its commands form what is called a vocabulary, and programs are made by defining new words and compiling them into a dictionary. So, why have you never heard of it? Well, basically, it bombed. So where does the Minstrel 4D come in? The Minstrel 4D is a Jupiter Ace compatible kit computer made by Tynemouth Software and sold by thefuturewas8bit.com. The original Minstrel kit came out some 5 years ago, and it was a clone-ish of the ZX80. That was refined into the Minstrel 2, still basically a ZX80. In 2019, the Minstrel 3 kit was a modern interpretation of the ZX81. The fourth iteration, or Minstrel 4th because it runs fourth, took a new tack. This time it was loosely based on the Jupiter Ace, and it could run Forth and Ace software. This new kit, the Minstrel 4D, is a refinement of the Forth with a built-in SD card slot, a turbo mode, more expansion slots, and an interesting type over mode that allows source code to be entered over a serial connection or from the SD card, and then processed as though it were typed on the keyboard. I've spent some time going through the manual and reading it and having a look. There's a lot that explains how the computer works with circuit diagrams and schematics and going through all the different modules. Maybe we'll talk about some of that later on. But for now, we are concentrating on building it, and the first part of the manual tells us how to build it. Part 1, low profile components. So we are looking at capacitors, resistors and diodes. Now the diagram is color coded, so capacitors are green, and we can see those. Resistors are blue, we can see those. Diodes are orange and red, and there's one orange diode and a bunch of red diodes. The orange is 1N4001 and the reds are 1N4148. So let's look at what we've got. That's the keyboard cover. Don't need that for now. And this is the chips and the sockets. So what have we got? Z80, ROMs, all sorts of other stuff. Okay, and revealed the PCB. Now, SD card reader rather is already attached. We'll obviously need an SD card for that. And this is nice. Each part of the board describes the function that it does. So this is the I/O decoding, which these are 74LS32, 668, 668. Clock is 7474, 32. Video circuitry. So that's the video controller chip. You can tell that because it's got a TV on it. I'm going to put the chips back into the anti-static bag because we don't want any damage happening to them. And that will go away for now. Right, I've got my trusty soldering iron switched on. I've got my anti-static band for when I need it. That won't be for a while yet. And let's have a look, see what we've got. So we've got resistors. These are the capacitors and the diodes. So we know within a little how big they are because of how many there are. So let's get started. Equipment we'll need: pair of pliers, pair of snips, a knife possibly, some solder, some flux, IPA, and of course a soldering iron. Right, I'm going to start with the diode. One more piece of equipment: magnifying glass. This is 1N4001. It goes in here. You can see where the bar is. So the bar goes to the bar, bend it over. There we go, the first component soldered. Now I'll just go through and do the other diodes. There's one up here. Spin them over, make sure they're all in the right way around. The soldering iron went into power saving. Just wait for it to warm up again. So now capacitors, we've got 2, we've got 3, we've got 4, and we've got lots. So the 2 should be 22 puff. Now there's just lots and lots of 100 nanofarad decoupling capacitors. Won't do us any good. And the final 4 are down here on the keyboard. Okay, before I go any further, I'm just going to check for short circuits across the voltage regulators. That's 5 volts. This I think is, whoops, good. The reason for doing that is that when I built the PET, there was a short circuit across one of these capacitors, these little decoupling capacitors, and it took a bugger of a job to find it. So, checking as we go along that there are no shorts means that we don't need to check it later. And so we come to the resistors. We'll start with this one, which should be orange, white, yellow, 390K, I think. As with the capacitors, we'll do the low quantities first. And so the last ones must be 10K. Okay, now once again I will just check against continuity across the voltage rails. Okay, that's good. And that is part 1, low profile components. Part 2, ICs and resistor arrays. Now, according to the book, we have green ones which are non-socketed ICs, and the red ones which are socketed ICs, and the blue ones which are resistor arrays. There are 3 of those, which you may not be able to see, so I'll just move that into the... Right, so there are 3 of those resistor arrays. The green ICs are not socketed, these are small logic ICs, and the red ones have sockets. And that corresponds this is approximately in the same position as they are on the board. So we've got that is there, so that socketed chip. Those 2 are there. That and that is there, and so on. But what I'm going to do, you see, I've got these little drawers of sockets. I am going to put sockets in the other chips as well, so I'm going to have everything socketed. Some of these, like these 20 pins, are turn pin sockets, and others, like the 14 pins, are just ordinary dual leaf jobbies. That's for example there. So in theory the non-socketed ICs go in first because they are the lowest profile, but we're going to do sockets for everything. Let's start with the sockets from the pack. So this is for the 80 mega, and what I'm going to do is I'm going to tack the corners, make sure it's home, and then we can solder the socket. Right, just wait for the soldering iron to warm up. Now I've got my anti-static wrist strap, but I don't think I need it while we're soldering the sockets, but we'll definitely need it when we're putting the chips in. We just do opposite corners. And then we can simply hold it and push it. And that's in, and we can solder the rest of the pins. That's the first one in. Second one's a big 40 pin chip, exactly the same principle. We'll just tack the corners. And then make sure it's home. Now it occurs to me I haven't got my little fan out, so I will remedy that. I really need a stronger fan. It does make a difference, but not a huge one. This is a 12 volt PC fan. If you've got any recommendations for a better fan to use, ideally a 12 volt one, because I've got the power supply for it, please mention it in the comments below. Okay, good. That's all the sockets from the kit. Now let's start putting in regular sockets. So exactly the same. Now I should say, in case you haven't already noticed, but there is a little notch at the top of the socket which denotes pin 1, and there's a little notch on the circuit board which also denotes pin 1. Pin 1 is the square hole at the top left. We need to just make sure that we put them all in the right way around. If you don't have the right size socket, you can always make it up with a combination of smaller ones. So a 16 pin socket you could make up with two 8 pin sockets. I'm going to push ahead with these other sockets. You really don't need to watch me soldering them, and so come back in a minute when it's all done. I was one socket short when it came to the 16-pin sockets, so this one is actually made up of two 8-pin sockets. But all the sockets are in. So before we go on, I just want to do another quick short circuit test. Make sure that we haven't shorted out the power rails. So ohmsies, and go across the output of the 7805, 23 mega ohms. That's no problem. That's no problem. That's no problem. That's no problem. So, okay, no short circuits. Now, what we have next is the resistor arrays. So we go to our little bag of bitty bits. And chapter 2 is done. Just check that we haven't broken anything. It's fine. What do we have next? MOSFETs and Regulators. It's this chap and this chap. 7805. So this is the 7805. FZ. No, sorry, F9Z24. Okay, that is confirmed. These are very difficult to read. You can bolt or rivet the devices in place before soldering to avoid stressing the solder joints. Alternatively, solder the tab to the PCB. I might solder the tab to the PCB. And I'm going to do it before I solder the legs. And the same with this one. There we go, and that is not flapping in the breeze. Crystal, piezo transducer and dip switch. Right, there's the piezo transducer. There's the crystal. And over here is the dip switch. So, crystal can be installed either way round, ideally with the writing writable. So that's that way. And when I say writable, of course I mean readable. There we go. The piezo transducer is polarized, but it's driven from an AC signal, and there is no marking on the board. The switch, align the switch so that the numbers are at the bottom and it's readable. Comme ça. Good. Leave the label on the transducer until we have cleaned the board. Green LEDs, red LEDs, electrolytics. Just tip the bag out at this point. Okay, the electrolytic capacitor. As usual, the negative side has got big minus signs on it, and it is the shorter lead. That's the BC548. Okay, we're rattling through this. Connectors. These connectors should be installed in the position shown. Ground tabs may need more solder or a higher temperature than the other connectors on the board. So we've got mic and ear, which are these little 3.5mm barrels. Now we've got DC, that's this one. Video out, that's going to be this chap. Ah, that's a clicky in one. And then this is a joystick. Again, that's a clippy in one, so that's good. And finally, there we go. All the soldering is now complete. More thing to solder is these 4 connectors. Now we have one angle connector like that, and 3 upright connectors like that. Now I think the angled socket should be easiest to do with a little bit of Kapton tape just to hold it down while we tack the edges. And just eyeball that to make sure it is flat, and it is. And so we can go along and solder the pins. Now these, what we can do is we can plug in a socket like that, and it's going to hold them straight. And in fact, if I get another socket, plug that in there, like that, that's going to hold them all straight. So all we need to do is tack down the ends. I just stuck the pliers underneath that corner just to keep it level so it doesn't rock. Okay, that looks straight. Let's solder it in. Okay, that completes the soldering. Now we come on to keyboard switches and pillars. So we have 41 light touch white tactile switches and 4 yellow tactile switches. These click solidly into place onto the PCB. Check to ensure the legs are not folded underneath. It's not necessary to solder the switches in place. You can solder them if you prefer. Okay, well, we'll try without. These are the switches. Now the yellow ones go on this side. And I think they could go either way around, it doesn't really matter. So they just push in like that. Awesome. Part of me says at the back of my mind, if they're not soldered in, and I ever need a switch for something, I can secretly cannibalize it. And one spare. Right, pillars. 6 8mm pillars, 5 13mm pillars, 6 10mm pillars, and 5 10mm pillars. Right, so the 8mm pillars go in the keyboard section, and the 13mm pillars go in that section. Because these are nylon, you really don't want to over tighten them. And now we come to the keycaps and the overlay. So rest the keyboard PCB over the previously installed 8mm pillars. Screw it in place loosely. Grab a screwer inner. Okay, that's going to help positioning the keycaps. Now cut out the keycap inserts, and I need some scissors. Back in a mo. You don't really want to see me cut out lots of little squares of paper, but just so that you can say I've done it, here's the last piece. Right, there we go. So now what we do is we assemble each keycap by inserting the paper insert face down into the clear cover and then locking it into place with the white one. And look at that, it's a 6. Now we may as well put these in as we go. Or not, as the case may be. Possibly I tightened these up too much. That did go on eventually. Done this before recently on the Amiga 600. Now, Brian, Z, right way up. I'm never going to live that down. Okay, let's tighten these up. Good, now we come to the chips. Now this refers to the last of the ICs, but of course we're putting all of them in at this point. And we need our trusty anti-static wrist strap. Let's start with the smaller chips. Let's go back to the previous page. Now this one, because it's an EEPROM, goes in from the bottom and any empty pins are at the top. Okay, there we go. As usual, we'll just do our quick short circuit test. Good. Right, now the moment of truth is to power it on and see if anything happens. So I'm just going to hook it up. Okay, so it's all set up. I've plugged in the video cable to the screen. The screen is on composite video. This is the 9 volts from the power supply, center negative. It's the same power supply as the mini PET. That's fine. Right, so first power on. Now all the chips are in and all the chips are the right way round. I've looked on the back, I haven't seen any solder bridges, I can't see any. I haven't cleaned the board yet, but that doesn't really matter at this stage. So let us plug in the power. Right. The power light does not come on because the mains is not switched on. So let's switch on the plug at the mains. Power light comes on. Apply power, every light should come on. They came on, they came, yeah. Then they went off. Hey, look at that, we've got the menu. Awesome! So, we proclaim this is working. Press T to load tut-tut. Just check that all the keys work. Good. Turbo mode works. So there we are. It is working. So now I've switched the Minstrel into reverse mode or inverse mode. So it should come up in white on black, black on white. And I've got an SD card in here. And I've downloaded something off the internet, which is from Mark G. Beckett on Dave Curran's Discord channel. And we're going to go 6, browse from SD. Ace Snow is what it is. And we're going to type it. Now what this is doing is basically auto typing. So it's reading the SD card, seeing the stuff on there, loading it in and pretending that I'm typing it at the keyboard. So it's actually entering the program. It will take a while. Okay, so now what we do is we type in its center and then snow. It's a bit cheesy, but it's Christmas. So this is the last video of 2022 from my channel, and I'd like to just say thank you very much for watching through the year. I hope you have a very happy Christmas or holidays or festivities or whatever you want to do during this next week or so, and we look forward to more videos in 2023. Please subscribe, like the video, and I will hopefully see you next year. Meanwhile, you can watch one of these videos that is coming up on the screen. Alright, that's it. I'm going. If you're still watching, why are you still watching? Well, I'm enjoying you still watching. See you next time. Have you got no homes to go to? Bye bye.